So now we've moved on. We've done a few questions where we found a missing side. Now we have situations and we can use trig to find a missing angle. So I've tried to use like a real life kind of problem. We've got a ladder leaning against a wall. The ladder is 6 metres long, okay, and the foot of the ladder is 2 metres from the wall, okay. So I've got that information there. The question is, what angle is the ladder making with the ground? So, if here's the ground, here's the ladder, what angle is this? Okay, and because we're finding an angle, we tend to label it with Greek letters, usually theta, but you might see these letters. You might see alpha, you might see beta, you might see lots of other things, but we don't tend to use x as a degree, not very often, all right, but any pronumeral could sit there. So we want to find that thing. We're going to use trig, and I'm going to show you a couple of little tricks to it. So we start the same way. We label the sides we've got compared to the angle we're interested in. So I'm interested in this angle. Okay, that's the one I really want to know about. Here's 90 degrees, so this must be my hypotenuse. This is the angle I'm interested in, so this is the opposite, and this is the adjacent. All right, so I've got this information. I've got this information and I want to know this. My opposite's not being particularly helpful for me. So I'm looking for a trig ratio that uses adjacent and hypotenuse, which would be cosine. So cosine theta equals adjacent on hypotenuse. Like every other equation, we substitute what we know. So cosine theta equals adjacent divided by hypotenuse. This is new. In every other situation, we've had an x and we've known how to undo it and to get x on its own. At the moment, we're taking the cosine of theta. In order to find out theta and undo that, we have to take the inverse of cosine. Now, that sounds really complicated. But I guess just think about it. When we used to have something squared and we wanted to find out what it was, say it said x squared is 40. The way we undid x squared to get x on its own was we took the square root. So we square rooted everything. Okay, we took the square root of this and the square root of that. This square root cancelled out that square root, if you like. They undid each other. So x equaled the square root of 40, which would equal a little over 6. So the opposite, or the inverse of cosine theta, is inverse cosine. So I'll show you how to write it because there's a specific way you need to write this. So we leave our theta here and we say it equals, and then we write cosine with a little negative power, cosine -1. All right, then we have a bracket and we write this fraction, 2 over 6. This bit here, this cosine -1, is called inverse cosine, okay? So we're taking the inverse of cosine with the number 2 over 6. So on your calculator, you use shift and cosine if you're using a regular scientific calculator. If you're using a graphics calculator, I don't know that you'll be able to see this, I'll try. You'll see there's a button that says cosine -1. So I just type in cosine -1, 2 divided by 6, and press equals, and that gives me that theta equals 70.53, and I'm measuring an angle, so I'm measuring a degree to 2 decimal places. What I'd like you to do is just check that on your calculator, if you put this in, that you get this result. Okay, because you need to make sure that you're using your calculator correctly. I'll do another question shortly, but hopefully you can see what's going on, even if it's all a bit of a new set of information.